All right, class. I gave this problem to you last week on the homework, but a lot of people were asking about it, so I want to make sure that I went over it again in case it came up on the exam. We have this problem that says, what is the probability of drawing two cards without replacement such that the first card is a queen and the second card is a club? The key to this is that there are two different cases we need to consider. The first case, let's suppose that the first card we actually draw is itself the queen of clubs. Okay, so the queen of clubs. If we draw the queen of clubs on the first draw, then the second card can only be one of the 12 remaining clubs. Okay? There are 12 clubs left to choose from. The other case that we can consider is that if we don't choose the queen of clubs off the bat, what if we choose one of the other queens? There are 3 other queens to choose from. If we don't choose the queen of clubs, then there's 3 queens that we could choose on the first draw. And then for the second card, there are only 13 clubs left that we could look at. Now, all right, we know that these are dependent events because we are doing these without replacement. If we don't replace the cards, then we do affect the outcome of every card that we draw afterwards. We know that the probability for 2 events that are dependent occurring at the same time, A and B, is just the probability of A times the probability of B. We know this as the multiplication principle. Okay? We know that for A or B to occur, the probability there is the probability of A occurring plus the probability of B given that A occurs. Okay? So we're going to use these 2 principles. This is the addition principle. We're going to use these 2 principles to determine the overall answer for this. Okay? Because in each of these cases, case 1 for example, we want this and this to occur, we're going to have to use the multiplication principle. For outside of these 2 cases, to join these 2 cases together, we're going to use the addition principle. All right? So we need to figure out the probability of case 1 and then find out the probability of case 2. Let's do that down here. So the probability of case 1 is the probability of drawing the queen of clubs. There's only one queen of clubs in a deck, so that's 1 out of 52. Okay, not too bad. From here, we use the multiplication rule to figure out the whole case probability. The probability of drawing 12 clubs, well, there are only 12 clubs remaining, and there's only 51 cards left because, again, we're not replacing. So the probability of case 1 is 1 times 12, which is 12, over 52 times 51. Okay? That's just for case 1. For case 2, however, we need to be a little bit more careful. The probability of drawing any of the remaining 3 queens, well, there's only 3 queens left out of the 52 cards, so that's 3 out of 52. Again, we're using the multiplication principle. Since there are 13 clubs, there are 13 clubs to choose from, but note again that because we're doing this without replacement, we only have 51 cards for the second card to draw from. The probability here, that's 3 times 13, forgive the slanting, that's 39 over 52 times 51. Now, because we want to find the total probability of this occurring, we need to add those 2 probabilities together. They have the same denominator, so we can go ahead and add those together. This should give us 51 divided by 52 over 51, but because there's a common factor in the numerator and the denominator, this simplifies to 1 out of 52, which is roughly 2%. Okay? So I just want to make sure I clear that up with everybody before the test next week. All right, thanks.